All right, welcome everyone. My name is Precious Ugweze. So here we want to show how this other formula for the dot product of two vectors was derived, the component-wise approach. Okay, so how do we go about this? Now you recall that by component-wise, if U is a vector in R3, what it means is that U is equal to U1I plus U2J plus U3K, and then your V is equal to V1I plus V2J plus V3K. Alright, so if we take the dot product, which is what we are looking for, so it means that we are going to have U dot V, and that is going to be equal to U1I plus U2J. Alright, so of course you know that our dot product, can distribute on this, bracket here. So what that means is that I can actually have U1I distribute on V1I plus V2J plus V3K, and then plus. All right, and so at this point, what am I going to have? So I can now open the bracket. So I'm going to have U1I multiplying V1I. Now, but before we go to this point, from the formula of dot product on geometric wise, where we said that U dot V is equal to the magnitude of U times the magnitude of V cos theta. So here we noted that if two vectors are parallel, that means theta is 0. So your U dot V will simply be the magnitude of this times the magnitude of that. Now, but if they are perpendicular, that means there's angle 90 between them, then U dot V is simply equal to 0. Now recall that from your three-dimensional plane, that if you have here is your J, that's on y-axis, here is your I on x-axis, and your K on z-axis. So all three are actually perpendicular to each other. Okay, so what's that going to give us? In this case, I times I are going to be parallel, and when they are parallel, we noted that the angle is 0, and so you are going to have cos 0, which will give you 1. We know that cos 0 is equal to 1, so you will be left with the two vectors only. So if I here multiplies the I here, we are going to get cos 0, which is 1, and so we'll have only these left. Okay, and if that happens, then when this multiplies this one, I is going to multiply J, and that's going to be 0. So everything here will turn to 0 for these two. Then we go to the third one. When this one now multiplies this, you will see that I will multiply K, and then it will be U1 times V1 times IK, with an IK is 0, which will turn this to be 0. And so it means that for all of these brackets, we only have this left. If you do the same here, 2U2J multiplying this, J will multiply I here to give 0, J will multiply J to give 1, and so you will now have plus U2 V2, and then J will also multiply K here to give 0. So out of this whole bracket, we'll have only this U2 V2, and then we'll go over to this U3K multiplying V1I. K times I will give us 0 again, and so that will be 0. K multiplying J will also give us 0, and that will be 0. But K times K will give us 1, and so we will also have here U3 V3, and that is our U dot V. Okay, so, and that's how we generalize to get the scalar product of two vectors on a component wise, even up onto n dimensional vectors. So assuming this is up to n dimension, it will continue up to u n v n. All right, and that is the proof for this formula, and that's where we'll end this video. We'll see you in our next video. Bye.